I've done a video on the hardening of steel and heat treatment of steel, and I mentioned this book, Workshop Technology by Chapman, W.A.J. Chapman, and it's all in there. And I think the one I did is very long-winded, very highfalutin. People may be sick of it and maybe switch off. So I'm going to put up this one first on the hardening of steel. Steel, the normal steel, we're talking about a bill hook such as this, will have about 0.3% to about 1.5% carbon, depending on the application. If it has under 3%, it's probably mild steel that you'll see doing buildings, putting up big buildings. That's probably mild steel. Wire nails are mild steel, very low carbon content, and they can't be heat treated. Okay, to harden and temper anything, you must heat it up. If it has the carbon content, you must heat it up. Its name is steel or perlite if you want to use it. When you get technical, you tend to lose people. You heat it up till it reaches its critical temperature, which is about 700 degrees centigrade. When you get it up to that heat, you can let it cool down, and that will soften it and make it more workable. When it reaches the critical temperature, it stops heating for a moment, and the carbon dots in it, or flakes, dissipate out into solution called austenite. When you let it cool down again, they go through the situation in reverse, and the austenite goes back to perlite, or steel, essentially, to cast steel or tool steel. Okay, that's that. If you heat it again, or you heat it from the start and get it through the critical temperature and get it beyond that, you're back to austenite. If you cool that in water and salt, or oil, cold oil or cold air, you stop its ability to go back through the critical process. It takes a bit of time to go through the critical process. On the way up, it takes extra energy. On the way down, it gives out heat, and you'll see it starting to glow again as the carbon goes back from a solution where it's all through, just like a scone or a cookie biscuit where you have chocolate instead of fruit. You have the chocolate in there. If you heat it up to a certain temperature, the chocolate will go through the bun or the pastry or the cookie, and it'll be all a kind of brown. With the chocolate, you can't undo that by cooling it, but if with steel, you can just cool it down slowly, and it'll go up and down like that all the time. Do you understand? Perlite, austenite, back to perlite. If you cool it suddenly, as opposed to letting it cool normally, you stop the critical temperature change, and you trap the carbon in the steel, and that's a form of diamond, and you create a substance called martensite. I'm just giving it to you. It's a very, very brittle, hard substance. That's it, you have that done. That's too hard for most applications, so you heat it up gradually to various temperatures, but not going past its critical temperature. And when you heat it up, you convert some of the martensite down to perlite, which is a soft substance depending on how much heat you put in, and cementite, which is a layered type of perlite. And you remove most of the hard martensite and you replace it with cementite, or you could have all cementite. A tine of a hay bob I broke recently showed the crystalline structure of cementite. There's a very definite structure. It's hard to define it. There's a crystalline, there's a various types of structures. Some of it's like salt, and some of it's brownie. You know, it's just hard to define it here. But that's the process: hardening and tempering. Some of Americans call it tempering and drawing, but we call it hardening and tempering. Do you understand that? It's an extremely useful thing. It's used by blacksmiths and everything. Now, I've done another video in which I've explained this in great detail, and I might put it up and I might not. It'll not do me channel any good, but the main thing is you only look at these if you're interested. Otherwise, don't look at them. Thank you very much. I've explained the hardening and tempering of steel with enough carbon to do it. The stub silver steel and gauge plate supplied from Sheffield in England is 1% carbon. That's pretty ideal. But 0.7, not to 1 is not a bad percentage. Okay, have you that? Ferrite is ordinary iron. Perlite is iron with a carbon content. Austenite is when it goes through the critical stage and becomes hot austenite. You can't have austenite except above the critical stage. You can't have austenite at 300 degrees centigrade. Can't have it. When you cool it, when you let it cool normally, you reverse the process. If you cool it quickly by dunking it into a tub of water, you create martensite, which is a very hard crystal brittle substance. It'll often crack on its own with the internal stresses. When you temper it by heating it again, but not up to the critical temperature, you take out a good deal of the martensite and you replace it with a substance known as cementite, which is very, very hard, but still it's slightly better. If you heat it even more, you bring in more of the perlite. So you can sort of undo some of the hardening without reaching the critical temperature by heating it gradually and either cooling it or letting it cool on its own. You can remove an awful lot of the hardness, and that's a very useful thing because it means that you can make your product for what you want. If you looked at the cap I made for the fluid tank of the machine, I had a video there a little while ago. The only part I hardened, the case of it was mild steel, probably about 1% carbon. The centerpiece was aluminium, not applicable. But the spring, there was a coil spring, and it would be put through a hardening and tempering process to make it bend. And I also had a little winged piece that engages in the tank. And if you've seen it there, it's blue coloured. It is hardened and tempered to be springable to a certain blue colour. And that is an example of the use of hardening and tempering in the workshop. I hope that I make that clear. I have a problem with big long videos, but this one's only 7 minutes. So if you look at this one and you're happy enough, you can look at the other one. It's up to yourself. I just have to go through it for the student or whatever. I might upload them on maybe on Rumble. I don't know. We'll see you back soon. Goodbye. Thank you.